So we are here with the next video, the topic binomial distribution, last topic of the chapter. After this video, this chapter will be done and you have to finish it in your notebooks. So let us understand what is binomial distribution. We had already done a chapter on binomial theorem in class 11th. So here also that formula is going to be used. So you should be knowing that formula. Let us see starting with an example. Let us understand this with an example, tossing of a coin. After tossing a coin, we'll either get a head or a tail. And I am considering getting a head a success. And I am denoting it with S and a failure with F. Means getting a tail. The probability of success will be, means either we are getting head or a tail, that is becomes 1 upon 2. Any number of tosses we will be doing, the probability of success will be again 1 by 2. Any number of times I will be throwing it, 10 times, 12 times, 20 times, the probability of success will be 1 upon 2 only. So thus these are known as Bernoulli's trials. Now if we want to know the probability of certain number of success, means if I am throwing the coin for 5 times and I need the success for 2 times, then what will be the answer? For finding out this, I am going to start from one number. Means if I am wanting one success in one trial, means I need success only, so that will be S. Now the second point, I need one success in 2 trials. 2 trials are there, so either it will be a success or a failure, means either it is S or F, or it can be F and S. Now the third thing, I am taking out 2 successes in 3 trials. 3 trials should be there, but the success should be 2. Either it can be a success, success, failure, or success, failure, success, or it can be a failure at the first point and then 2 successes. And if I need one success in 5 trials, it will be S, F, 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 and these kinds of 4 terms. But how long we can be writing all these terms? It's a tedious task and a time consuming task which many times will be wrong also. Now if we want to take out the number of successes and according to the number of trials, we have to derive a formula. So we are here for deriving a formula which we'll be using for the questions of binomial distribution. So let us derive the formula. Let X denote the number of successes in a trial. Success, I am denoting again with a S, means occurrence of a head. P, small p, always will be representing probability of success, and Q will always be representing probability of failure. If we toss a coin once, the possible outcomes can be either a head or a tail, means either a success or a failure. Tossing a coin once only. If we are getting a success, then it will be 1. And if we are getting a failure, then X will be 0. Because what I had considered the rule over here. We are denoting the number of successes in a trial. So number of successes will be either 0 or 1. So probability of X is equal to 0 means when a failure is there, it is Q. And when X is equal to 1 means probability of success. We denote it by P, and just with the distribution table, for X is equal to 0, the value is Q, and for X is equal to 1, the value is P. This is for the one coin. Now if we toss a coin twice, this was tossed for one time, a single coin. Now we are tossing a coin twice. These are the options which we can get. Means 2 successes or 2 failures, 1 success, 1 failure, or 1 failure or 1 success. So here the X is taking values 2, 1 or a 0. Now if we find the probability for getting X is equal to 0, it will be probability of FF. Means both the failures are there. Or I can write it as probability of F into probability of F, which is Q into Q, Q square. Similarly, when we find at X is equal to 1, that will be the probability of getting a success and a failure, and probability of failure and a success. We had written here probability of success into probability of failure plus probability of failure into probability of success. Putting the values P into Q plus Q into P, we can write it as 2PQ. This was Q square and this is 2PQ. Now we will be finding the probability at X is equal to 2. At X is equal to 2, it will be probability of SS, means probability of success into probability of success, which will be P into P, that will be P square. And see the table? Again I am putting it into the table. 0, 1 and 2. For 0 it was Q square, for 1 it is 2PQ and for 2 it is P square. Similarly, if we toss the coin thrice, if we are tossing it thrice, then see X will take the values as 0, 1, 2 and 3, and these will be the values. And you can see this, if we add this is P plus Q whole cube. If I add this is P plus Q whole square. And the first one was P plus Q to the power 1. After observing these all probabilities distribution, we can say that the probabilities of 0, 1, 2 till n successes, we can obtain it by the first, second, third term or n plus 1th term in the expansion of Q plus P to the power n. I told you when I tossed the coin once, it was Q plus P to the power 1. When I tossed the coin twice, it was Q plus P to the power 2. And when I tossed the coin thrice, it was Q plus P to the power 3. And similarly, if it will be tossed n times, it will be Q plus P to the power n. Now I am putting it in the distribution table. For 0, just expanding this according to the binomial distribution, binomial theorem which we have read in class 11th. This is the first term, this is the second term, this is the third term, and this is the nth term. This is nth term. Here the parameters are mainly n and p. If I get p, then easily I can find q and we can just complete the full probability distribution table. Now how we will be finding it? For using it in the questions, how we will be doing it? If we consider the probability of x successes, okay, we are finding out for x successes. It will be given there number of successes and how many number of trials we are using. So here we are considering it as x. Then probability of x will be ncx q to the power n minus x p to the power of x. This is a general formula of binomial theorem. So we had put it here. And we had expanded this ncx. This can be written as n factorial upon x factorial into n minus x factorial. The remaining two things remain the same, where x is going to take the values from 1, 0, 0, 1, 2 till n, and q is 1 minus p, because p plus q means success plus failure is equal to 1, where px, this px is called the probability function of the binomial distribution. So basically this is the formula which we are going to use in our binomial distribution questions. Let's do one example. You will be able to understand more clearly और ज़्यादा अच्छे से समझ में आएगा, and you will be able to do exercise 13.5 because after this video you have to do with exercise 13.5 and finish your work. Example, see this. If a fair coin is tossed 10 times, find the probability of exactly 6 heads. So it is 10 times, this is the value of n. 10 times we are tossing any coin and probability of exactly 6 heads. So the value of x will be 6. Let x denote the number of heads in an experiment of 10 trials. Here n is 10 because it was tossed 10 times. Probability of getting a head will be 1 by 2. So getting a tail means failure will be again 1 upon 2. So using this formula, I had written a formula over here, ncx p to the power x q to the power n minus x. Substituting these values, substituting the value of n, p and q, I am getting here 10cx 1 upon 2 to the power of x and 1 upon 2 to the power of 10 minus x. We know the rule of exponents. When the base is same, powers can be added. After adding x plus 10 minus x, we can see that an x and minus x will be cancelled and we'll be left with 1 upon 2 whole to the power of 10, 10cx. Now putting the value of x is equal to 6. Putting x is equal to 6, so it becomes 10c6 half to the power of 10. And after solving this, 10c6 can be written as 10 factorial into 4 factorial 6 factorial, and after solving all this value I am getting here 105 upon 502. So this is the way we can find it out. Any number of probability distribution table, we can find the probability of any number of times we are tossing the coin or we are throwing a die or anything, where we can find the number of successes, number of failure, and how many times we are going to do that event. So now you have to, in the homework, you have to finish with exercise 13.5. So homework, I am writing it here. Complete exercise 13.5 means finish with the chapter.